Hello friends, welcome again. This is Vijay Lohar and today we are going to discuss about some more topics of IP address, subnet mask and of course about subnetting. In previous video, we learned about IP address, subnet mask, classes of IP address, range of IP addresses, network portion of IP address, host portion of IP address and so on. For further topic, that is the subnetting, we just take an example. If we use an IP address range of class C, we get 254 hosts. If we use IP address of class B, we get 65,534 hosts. And if we use a class A network, we get lots of valid host address at about 16,777,214 hosts in a single network. It's all because of their default subnet mask. As subnet mask contains on bit and off bit, all the off bit defines the host portion of IP address and number of hosts, how many hosts will be in a particular network, and all the on bit of your subnet mask defines the how many network can be created in a particular class of IP address. But what if we have only 50 computers in our network? We may use any range of IP address of class C, like 192.168.0.0 network with the default subnet mask 255.255.255.0, which provide the range of 1 to 254 hosts. So we can easily assign IP address to 50 computers from this range. But what will be about the IP address which is not assigned, that is about 204 IPs, which will be wasted at all. Let's take another example. What if we required 500 hosts in a single network? A class C network cannot assign 500 continuous IP address, as it is bounded to 254 hosts only. So we can prefer for class B, which default subnet mask is 255.255.0.0, and the subnet mask will provided 65,534 hosts per network. We will use continuous 500 IP address, but what about the rest IPs? That will be totally wasted. And so on in class A. If we need 70,000 IP address in a network, we will have to use a class A IP address, which will provide us 16,777,214 hosts. And after using 70,000 IP address from this range, all the rest IP address will be wasted. But as an network administrator, we all should consider that there is a limited number of IP address. The maximum possible IP address we can get from the range is 2 to the power 32 bit, whatever the number will be, but that is the limit of our IP address. We cannot have much IP address in 32 bit. So what address we will assign to new computers if we don't have any unassigned IP address at all? To overcome this problem, the concept of subnetting comes in. Assigning IP address with default subnet mask is not acceptable anymore, as it provides only three ranges, that is 254, 65,534 and 16,777,214 host range. So breaking a default range of IP into multiple small subnetwork according to our host requirement is called subnetting. And how we can do that? The basic concept of subnet mask says minimum the zeros in subnet mask will minimize the number of host IP per network. Like in class C, subnet mask 255.255.255.0 in binary, first 3 octal all bit will be high, and last octal all the bit will be low. So we are getting 8 bit for the host, and if we calculate with the formula 2 to the power n minus 2, where n is the off bit of subnet mask, it will be 254 hosts in a network. Let's take another example. For class B, which provide us about 65,534 hosts in a network from 16 op-bit. 2 to the power 16 minus 2 will be 65,534 hosts per network, and so on. In class A, subnet mask is 255.0.0.0, and in binary we can see that there is 24 op-bit for host. So 2 to the power n is the op-bit. So 2 to the power n minus 2 will be 16,777,214. As we can see above, minimizing zeros bit in default subnet mask can minimize host per network, and maximizing 0 bit in default subnet mask can maximize the number of hosts per network. Before starting any further about subnetting, I prefer you to remember this equation, or I am going to tell you about the place value of on bit in your subnet mask. That we can understand that each octal is having 8 bit, and what is the place value of that 8 bit is, first is 128, second is 64, third is 32, fourth is 16, fifth is 8, sixth is 4, seventh is 2, and 8th is 1. This will help you to understand how to minimize or maximize your subnet masks on bit or off bit. Like when all the off bits in your octal, the decimal value will be 0. When first bit of your octal is 1 and rest 7 bit is 0, the decimal value will be 128. When first 2 bit of your octal is high and rest 6 bit of your octal is off, then the value the decimal value will be 192, and so on. When the first 3 bit will be on, it will be 224. When first 4 bit will be, is on, it will be 240. These are the decimal value. When the first 5 bit is on, the decimal value for the octal will be 248. When the first 6 bit is high, then the decimal value for this binary number will be 252, and when the 7 high bit in your octal, it will be 254, and when all bit of your octal is high bit or on, the decimal value is of 255. So when we write 255.255.255.0, actually it is all 24 bit on and last 8 bit is off bit. So if the subnet mask is 255.255.255.0, the binary will be 11111 8 times once in first octal and second octal and in third octal, and the last octal will be 0. Total host in this network will be 224, and it will comes from 0 bit, that is 2 to the power 0 bit minus 2, that will be 254. What if we manually use subnet mask as 255.255.255.128? There is a subnet mask I have given there, that is 11111. Actually that is not a 24 bit subnet mask, this is a 25 bit subnet mask. I have manually added 1 in last octal. So what will be the default subnet mask for the for this will be 255.255.255.128. the 128 is the decimal value for 1.10000, the last octal one, and the host will be in this subnet mask, the host will be 2 to the power n minus 2, that is 2 to the power 7 minus 2, which will be 126. How that 128 comes? That is from this equation. Look at the first 0 and second one is when the first bit of your octal is high, the decimal value is 128, and so on. It comes here. All the on bits means 255 and 1 on bit, and all off bit is 128. So if we assign subnet mask of 255.255.255.128, we will get only 126 hosts per network. We are breaking a default network slot in pieces, or we can say we are breaking a network to subnetwork. This process is called subnetting. Let's take another example, like we have a network assigned 172.16.0.0. 172 says that it's a class B network, but we need 200 hosts only. Just manually add 1 in your default subnet mask. The default subnet mask is 255.255.0.0. It means first 16 bit is on and second and third 16 bit is 0. Like you can see here, all the 1 which is with red is manually added once to minimize the host number in class B. You can see there is 255.255.255.0. It looks like a class C default subnet mask, but it's not actually class C. We have manually added once in third octal, so it looks like 255.255.255.0. Actually that added number, added 1 is the subnet bit which we have added manually to minimize the number of hosts from 65,534 hosts to 200 range. So if we assign an IP address of 172.16 range with subnet mask 255.255.255.0, we will get 254 hosts only, but we cannot add any one more in your subnet mask because the value of zeros in your subnet mask will be 7, and 2 to the power 7 minus 2 will be 126. That will not be 200. So we cannot get our required IP address, that is 200, from this subnet mask. So we will use 255.255.255.0. So now by subnetting we are not actually following the default class of default subnet mask, but we are manually managing subnet mask according to the host requirement. We can save much IP address with this method and we can use in our required network. So thank you guys. I hope you get more detailed knowledge about subnetting. If you like this video, please don't forget to subscribe and share this video. In next session we will discuss about CIDR, that is classless interdomain routing, and VLSM, variable length subnet mask. Till then, good luck. Bye.